By at this time, all participants are in a listen-only mode until the question and answer portion of the program. I'd now like to turn the call over to the Jet Propulsion Laboratory. Thank you.
Thank you, and welcome everybody, and apologies for that slight delay. We have everything ready to go now. I'm Jane Platt from NASA's Jet Propulsion Laboratory in Pasadena, California. After 13 years of exploring Saturn, its moons, and its rings, NASA's Cassini mission is wrapping up its long journey with a series of orbits leading up to a dramatic finale on September 15th. Today we'll hear a recap of some mission highlights, and we'll get a preview of what to expect in this final phase. We're going to hear 3 brief presentations from speakers and then take some questions. If you do have a question, press star 1 to be placed in the queue. And the visuals to follow along with are at www.nasa.gov/Cassini telecon. www.nasa.gov/Cassini telecon. Quick intro of today's speakers. We have Kurt Niebuhr, the Cassini program scientist at NASA headquarters in Washington. Earl Mays, the Cassini project manager here at JPL. Linda Spilker, the Cassini project scientist at JPL. First, we will hear from Kurt Niebuhr. Kurt?
Thank you, Jane. As Jane mentioned, the Cassini mission is coming to an amazing end after our adventure, and it has been a very long adventure. The first thing I want to do is congratulate the team for building such a remarkable spacecraft and operating it so masterfully for all these years. Their work has been absolutely extraordinary, and I'd like to put their commitment and their skill into just a little bit of context. Work on the Cassini mission began in the late 1980s, about 30 years ago. That was a few years before the Internet became available to the general public as the World Wide Web. Desktop computers were exactly that. They covered your entire desk. A cell phone was the size of a brick. It cost $8,000 in today's money, and all it did was make phone calls. No email, no Angry Birds, and streaming video meant that your VCR was broken and spitting out magnetic tape into a tangled pile on the floor. This is the level of technology that the team worked with while building and operating this mission, and they did a superb job. It's been an absolute privilege to work with all of them on this mission. And the mission has exceeded all of our expectations, done better than we could have ever dreamed. The Saturn system is absolutely chock full of amazing worlds of all sizes, and Cassini has been exploring them for the past 13 years. Since our arrival in 2004, we've watched the seasons change on Saturn, which is just an incredible opportunity considering a year on Saturn lasts 29 Earth years. We've watched the particles in the rings around Saturn collide and glide during their gravitational dance, and we've confirmed things that we suspected might exist in the Saturn system. But even more pleasantly, we've been shocked by things that we never predicted we would find. If you can bring up the first graphic, Niebuhr 1. In the top right corner there, you see a picture of Saturn and its rings. We watched a massive storm near the upper part of Saturn just erupt in what we expected to be a relatively easygoing and quiescent Saturn atmosphere. And that storm traveled around the entire planet, eventually bumping into itself and eating its own tail. We saw in the lower right corner one of the truly weirdest features in the solar system, a long-lived hexagonal storm or cloud feature that's the size of the Earth and weirdly centered on Saturn's North Pole. And that hexagon has been there for decades upon decades. We confirmed the presence of methane lakes on Titan in the top left corner. But more importantly, what we learned is that this huge moon is in fact a dynamic world with methane seas and rain and rivers on its surface. And we were absolutely shocked to learn that tiny Enceladus has a global liquid water ocean underneath a relatively thin ice crust that's warmed by hydrothermal activity at the bottom of the ocean, and has jets of the water from that ocean shooting out into space through cracks in the South Pole. Enceladus may have all of the ingredients needed for life as we know it to currently exist right now, this very second. These two new worlds, Titan and Enceladus, that were so completely revealed to us by Cassini, have changed the idea that ocean worlds like Earth and Europa are rare in the universe. And this, in turn, is changing our views about finding and about how prevalent and common habitable environments and even life beyond Earth might truly be. And this is just a taste of Cassini's discoveries. The list goes on and on. The mission has been insanely, wildly, beautifully successful. And it's coming to an end in about 2 weeks. But Cassini will not go quietly. As our propellant supply dwindled, the team put forth a frankly brilliant idea to dive the spacecraft over and over between the narrow space separating the rings and the cloud tops of the planet. These dives, the grand finale that you've been hearing about, have used the remaining dregs of fuel that we have to pursue questions that we never expected Cassini would have the opportunity to answer. Completely new science that we're going after. The Cassini mission has taught us so very much. And to me personally, I find great comfort in the fact that Cassini will continue teaching us up to the very last second on September 15th. And at this point, I'd like to turn it over to Earl Mays, who is the project manager.
All right, thank you, Kurt. Before we jump into the grand finale, I'd like to take just a moment to look back at some of the mission's really amazing statistics. So if you could bring up Earl Mays number 1. It's a Cassini-Huygens by-the-numbers graphic, and for nearly 20 years, this spacecraft has now logged almost 5 billion miles and has put it in 294 orbits around Saturn and another 2 around the Sun. Absolutely phenomenal spacecraft and a phenomenal mission. There have been nearly 4,000 scientific papers written, peer-reviewed papers written by developers and researchers in 27 nations. I can't emphasize enough how truly international collaboration this mission is. 27 nations participated, 19 were participating at launch. We added another 8. The thing I'd like to emphasize, maybe Kurt caught it already. Our computer stats might be a little modest by today's standards, but remember, we were using 1980s technology, so 635 gigabytes in 1987 was pretty tall cotton. So we're pretty proud of that, even if that. And also keep in mind it was, a billion miles away, and it took a long time for that stuff to get back down here. So the one other thing I want to emphasize just quickly is the 162 targeted flybys of Saturn's moons. That's Titan, the large ones, Titan, Mimas, Rhea, Dione, Tethys, and a lot of the small ones as well. But I want to particularly emphasize Titan. 127 flybys of Titan. Cassini's had a long-distance, you might say, long-term relationship with Titan. Each of these flybys, Titan has shared some of its secrets with us and at the same time shaped Cassini's trajectory. We've used that Titan flyby, which is equivalent of over 1,000 pounds of propellant every time. We had 127,000 extra pounds of propellant on board this spacecraft that we were able to use to investigate the entire system. On April 24th of this year, our 127th and final close flyby of Titan put us into what we're calling the grand finale. So let's just go to the next graphic to see Earl Mays number 2, if you wouldn't mind. This is what we have been doing for the last 4 months. That graphic conveys the entire 22 orbits of the grand finale mission. It was, as I said, on April 24th, the flyby of Titan slowed us down just enough to get in between the rings of Saturn and the atmosphere. Not too deep, not too far away. It's been a perfect shot, and great kudos to the mission designers and navigators that found and operated this trajectory. So this is a 2 million mile view of the entire finale. 22 orbits, each of them 6.5 days long, racing between that gap between the rings and the planet at about 75,000 miles per hour. We've completed 20 of those orbits, 2 more to go, and every instrument on the spacecraft has been active, and most have been prime at some point. It couldn't be better at this point. We have had exceptional performance, and we could not have asked for much more. It has just been a phenomenal ride. I want to zoom in on the gap and show you some of the challenges we've had with going into this unexplored territory. And I should say unexplored. No spacecraft has ever gone in this region before. So go to slide Earl Mays number 3. This is a graphic of our final 22 orbits. Actually, you'll see on the far right 23rd. But that's the entry into Saturn's atmosphere. And you see what's happening here. On the bottom is our time scale. Each of those dots represents the distance between the D-ring, the innermost ring of Saturn, and the atmosphere where Cassini is gone. They're more or less approximations. You can see we had 4 right in the middle, and then 2 up in the dust, 3 down, 2 up, and then 5 down again. Each of those jumps, well, guess what? That's Titan again. Not so close, but giving us little nudges back and forth, and we've been able to exploit those ranges in order to accommodate different scientific investigations. But as I said, this is unexplored territory. So the first thing the flight team did when we thought we weren't sure we were going to make this first plunge, and I have to back up and say we would never have done this at any other time of the mission when we knew we were going to run out of fuel and crash, because there's just so many uncertainties in this environment. However, they've come out quite well. So for the first flyby, we used the shield of the antenna of the Huygens antenna of the spacecraft as a shield to protect us from the dust. Not quite certain we were going to survive. As it turned out, the dust we thought was there is remarkably missing, and we were able to actually relax our shielding policy on some of these other flybys in order to take advantage of the more advantageous orientation. For example, the 4 flybys in the inner ring boundary had planned to use the Huygens antenna as a shield for those as well, and were able to relax one of those. The other 3 right there in the middle were fine, and again, the next 5, after Titan pushed us back down out of the dust, were also quite fine. Each time we were alternating instruments and investigations. Then another Titan flyby pushed us down into the outer edge of the atmosphere. Again, we're relying only on models and observations, remote observations, to guess the environment. So we weren't sure if it was going to be too thick and it would turn us out of control, push us out of control, or too thin, and the instruments that wanted to sample the atmosphere weren't going to be able to be effective. So we had 3 different contingency maneuvers there. We had a pop-up. If the atmosphere were too thick and was going to affect the spacecraft adversely, we would pop up out of the atmosphere. If it were too thin, we could pop down in. With apologies to Robert Southey and to the exoplanet people, we are in the Goldilocks zone. We have hit the perfect spot. We are getting duty cycles on our thrusters of about 40%. Up to 100% is fine. And so we are seeing atmosphere, lots of it, that the INMS, our mass spectrometer, can sample, but the spacecraft can handle. So the pop-ups, the pop-downs, all those contingency maneuvers are now back on the shelf. We have declared as of yesterday no more OTMs or trajectory changes for the spacecraft. Our final maneuver is behind us. So with those final 5 orbits, we are now on our way into the grand finale. So what I also want to just take a brief moment to explain is this atmosphere drag. We've been publishing a lot of different end-of-mission times. I think if you look back at our history, we're at 5:08. I think we're at 4:54. Now we're at 4:55. This is all because of our uncertainties with Saturn's atmosphere. It is you're watching engineering and science in action as we modify our estimates and get better and better. Now we're pretty confident now. We think we've got it down within a few tens of seconds. But Saturn continues to surprise us over and over again. When we think we know what's going on, there's either no dust where there should be, there's atmosphere that's heavier than we thought and then thinner. So stay tuned. We'll have a good number for you on September 13th. Let me go to the next trajectory just to show the final day. This is an animation. This is the last 2 orbits, and if you play it, you will see Titan coming along one last time. As I said, we've had a long-term relationship with Titan, and I don't mean to be too romantic about all of this, but what you'll see after the spacecraft goes through a couple of orbits is Titan coming in from the bottom and actually deflecting Cassini into its final trajectory into Saturn. So, and this thing will loop a couple of times. If it goes by too fast, you can play it again and again. But that final flyby of Titan on September 11th will put Cassini on an impacting trajectory, and there is absolutely no coming out of it on this one. We are going so deep into the atmosphere that you just don't have a chance. The spacecraft doesn't have a chance of coming out. So that final kiss goodbye from Titan, as I said, I don't want to get too romantic about it, but that really is our last flyby, and we will start to enter Saturn's atmosphere very early on the morning of September 15th, at least California time. It'll be a little bit more reasonable for those of you on the East Coast and in Europe. Now, if I could go to the last graphic, I'll just quickly walk you through the final day's events. What we've got on September 11th, as I mentioned, that's the flyby of Titan that will take us onto our final plunge trajectory. Then there's some other observations. We'll play back the Titan data, and then we will begin to start to examine perform what we're calling the last picture show, a final set of images of some of the selected targets in the Saturn system, and that's going to go on until 12:58, nearly 1 o'clock in the afternoon here, when our last image will be taken. The Cassini spacecraft will turn back to Earth for the very final time, and for the next 11 or so hours, begin to play that data back down. There'll be a lot of images, also all fields and particles in situ instrument data. We will make those images available to you and to the world as soon as we possibly can. At about 1:37 that evening, actually the next morning, our time, Cassini is going to reconfigure for its final plunge. What we've been able to do, and this is great kudos to the spacecraft team, is turn Cassini into an atmospheric probe. As the data is measured, rather than being stored on our recorders and played back later, it will be sent to the Earth almost immediately. A 2 or 3 second latency is all we're expecting. So we will have repurposed Cassini into an atmospheric probe, and we'll have it broadcasting data back down to the very, very last minute. So for the last 3 hours, we will be essentially pointing at the Earth, rapidly approaching Saturn, and as the spacecraft loses control and eventually burns up in the atmosphere, we'll get data as long as we possibly can. That's the grand finale in a nutshell. I do want to take just a couple of moments to acknowledge that not only is this an incredible engineering and scientific achievement, it is a human achievement, and particularly the human effort that has accompanied it with the operation of the mission. The engineering and science and navigation teams have just done a phenomenal job in getting absolutely everything they possibly could out of this mission. The spacecraft has been used to its fullest, and I can't say enough about the operators and the scientists that interpreted this data and shared it with the world. And with that, I turn it over to Linda Spilker to talk about the science.
Great. Thank you, Earl. I worked on Cassini since 1988, and in those early days, I gave most of my presentations using an overhead projector and view graphs. How times have changed. Well, as it has been mentioned, Cassini's grand finale has been every bit as rewarding scientifically as we had hoped. Now, you can only go someplace once for the first time, and for Cassini, that place is the region between the rings and the Saturn. And this is the first time that any spacecraft has flown through this region so close to the planet. For comparison, last week I just experienced my first total eclipse. It was so much more incredible than I had imagined. And in the same way, Cassini's grand finale is just as amazing and fascinating. If we go to Spilker 1, it shows an interior cutaway of Saturn. Some of our key science goals during the grand finale are trying to understand Saturn from the inside out, to figure out the length of a Saturn day, and to determine the mass of the rings and the composition of Saturn's atmosphere. Our understanding of this fascinating new data is still evolving for me and the science teams. There are so many puzzles at Saturn. I just want to give an update on a few. The interior of Saturn, the lack of a tilted magnetic field, is a great puzzle. Our models tell us that you need an offset to keep the currents flowing that create the magnetic field. And if you look at the other planets in our solar system with magnetic fields, all of their magnetic axes are tilted with respect to the rotation axis. Now, this lack of a tilt is making it tricky to determine the rotation rate of Saturn for its interior, and that's key to understanding the circulation models for Saturn. The gravity field of Saturn does not match our models either. Saturn's gravity field is much more different from Jupiter's than we initially thought. Perhaps its source might be deep winds or strong differential rotation, or the top of the atmosphere is rotating more quickly than the lower atmosphere, or it could be so much more. The first estimates of ring mass point to less massive rings. However, we must sort out Saturn's gravity and interior first before we can determine the mass and the age of Saturn's rings. We've been sampling the composition of the upper atmosphere, particularly in the last couple of orbits, with our mass spectrometer, and we're observing a more complex both chemical and dynamical interaction of Saturn's atmosphere with the rings than we had anticipated. The dynamical interaction involves both the ionosphere and the neutral atmosphere, and the chemical interaction involves both water molecules and hydrocarbons. Now, all of this is actually good news. Scientists love mysteries, and the grand finale is providing mysteries for everyone. Over the next 2 weeks, we're doing the kinds of things we've always done, but of course, there's nothing ordinary about exploring Saturn or our grand finale region. As Earl mentioned, Cassini's final images will be our last look around the Saturn system. If we go to Spilker 2, that's a montage of our final targets. These images will be taken on September 13th and 14th and returned to the Earth on September 14th. These final images are sort of like taking a last look around your house or apartment just before you move out. You walk around the downstairs. As you go upstairs, you run your fingers along the banister. You look at your old room, and memories across the years come flooding back. And in the same way, Cassini is taking a last look around the Saturn system, Cassini's home for the last 13 years. And with those pictures come heartwarming memories. In the upper left-hand corner, there's Titan. We're going to be taking our last look for Titan's weather. The upper right-hand corner is Enceladus. We're actually going to watch as Enceladus sets behind the northern limb of Saturn. On the bottom left is a feature created by this tiny particle, Peggy, this tiny moonlet. We'll be looking to see if perhaps Peggy has broken free from the rings and becoming a moonlet in her own right. In the center bottom, there's a view of the propeller. That propeller is created by an object a little smaller than Peggy, trying to open up a gap in the rings. And finally, on the lower right, we'll be taking a color montage of Saturn plus the rings, and also getting information about the aurora around the North Pole of Saturn. So our final look, our final memories coming back with these pictures, because you see, Cassini is not taking any images during the final plunge because we don't have the data rate to send them back in real time. So our focus is going to be using all of our instruments to sample the atmosphere of Saturn. So let me tell you a little bit about science during the final plunge. If we go to Spilker 3, there you see that 8 Cassini instruments are on at the time. All 5 of our fields and particles instruments, including INMS and MIMI, the radio and plasma wave antennas, cosmic dust analyzer, as well as the magnetometer. Our infrared and ultraviolet spectrometers will be on and taking data, as well our radio science system. Now, the highest science priority is to sample the atmosphere, as all of these instruments will be doing together. And as has been noted previously, this new science is making Cassini Saturn's first atmospheric probe, although Cassini will only sample the very top of Saturn's atmosphere and will be sending back data until the very last second. We stand to gain fundamental insights into Saturn's formation and evolution, as well as the processes that occur in the atmosphere. Well, during this time with Cassini, many of the scientists and I have worked on Cassini for almost a full Saturn orbit, and that's almost 30 years. And there's been an incredible effort by the scientists to both build the instruments and then to now analyze the final science. We've watched Cassini being built, launched, flown to Saturn, and orbiting Saturn for 13 years. And our families have gotten to know each other. We've taken vacations together. In some cases, our children have grown up together. And now, in the final 2 weeks, we're sharing the end of this incredible mission. In the grand finale, Cassini has been giving the scientists surprising new mysteries to be solved, the equivalent of gift-wrapped presents. Who knows what new mysteries the next 2 weeks will bring? And the answers to some of these scientific puzzles may turn out to be some of the very best science of the mission. These final days of the grand finale are all a part of Cassini's grand goodbye.
All right. Thank you, Linda, Earl, and Kurt. And you mentioned what a family Cassini is. Should point out that we have 3 other people from the team in the room with us today in case there are any questions that would be more appropriate for them. We've got Julie Webster, the spacecraft operations manager. We have Eric Sturm, the mission planner, and Scott Edgington, the deputy project scientist. Good to have you all here with us. All right, we're going to go over to reporter questions now. And again, if you do have a question, please press *1. Tell the operator your name and affiliation. We do have quite a few reporters on the line, so we're going to limit ourselves to 1 question and 1 brief follow-up on the first round. And then if we have time, we'll go back to others. We also are taking a few questions from social media. All right, let's take our first question from Kella Cofield of Space.com. Kella?
Hi, I have a question for Dr. Spilker. I was wondering if you could talk a little bit more about what exactly you're hoping Cassini will tell you about the composition of the atmosphere that you haven't been able to learn using, say, spectroscopy or other methods.
Well, by having in situ sampling of the atmosphere, we can directly measure things like the hydrogen to helium ratio. We can directly measure composition of perhaps constituents at a very, very low level in the atmosphere, things that would be much harder to see from a distance with remote sensing and spectroscopy. And all of this will tell us about the evolution of Saturn's atmosphere, especially maybe we'll get a handle on some of those seasonal changes.
Okay, and our next question is from Marcia Dunn at Associated Press. Marcia? Marcia, can you hear us? Are you ready with your question? If not, let's go ahead and take the next question, which is USA Today.
Hello, can you hear me?
Yes, I'm sorry. Is this Marcia?
Yes, it is. I'm sorry. Yes, can you hear me now?
Yes, we can definitely hear you, so go ahead with your question. Thank you.
Thank you. Dr. Spilker, I see that Cassini has discovered 6 named moons. How many moons altogether has Cassini discovered, named and unnamed? And do you have any idea what the very last photo taken by Cassini will be of?
I'll start with the last question. The very last photo of Cassini will be of the propellers in the Saturn system. As far as the unnamed moons, they're not named because these moons may not stick around for a long time. And a good example of those are the tiny objects that are associated with Saturn's F ring. We've given them sometimes names with the year and the time that we've actually seen them. And so we just have 6 named, and then these other objects that we're not sure what they are. And in the case of Peggy, that's just an informal name for an object that may or may not come out of the edge of the A-ring.
Okay, and a reminder to reporters that we do, if you do have a question, we do need you to press *1 so the operator can put you into the queue and we can get your question. In the meantime, I'm going to take a question or 2 from social media, and that is from Lars Holm on Twitter. What is the distance of Cassini from the cloud tops? Who would like to answer that?
I'll give that to Eric.
Okay, Eric Sturm, the mission planner. Eric?
The closest it gets to the clouds, well, in some respects, it's flying through the very upper atmosphere, so it is in clouds. The closest it gets to the deepest it could possibly go in the atmosphere is about 200 kilometers or 120 miles. What we consider the quote surface of Saturn, which is the 1 bar altitude, which is the equivalent pressure that the surface of Earth has, it's several thousand kilometers above that distance.
Okay. Thank you. And now we have Irish TV, Leo Enright. Hello, Leo. Okay, we seem to be having a couple of little issues here. We'll try to clear that up. In the meantime, let's take a question.
Can you hear me, Jane?
Hello, is that you, Leo?
Jane, can you hear me?
Yes.
Okay, thanks, Jane. I'll keep it simple then. I'm a TV guy, but I'm also a radio guy, so this question obviously is for Linda Spilker. The radio and plasma wave experiment, is that going to produce something during those end-of-mission moments that we're going to be able to hear?
One of the things that we can hear with our radio and plasma wave antennas.
If you'd like to ask a question, please press star 1.
Back to us through those antennas. And also sometimes there are other phenomena that are present around Saturn, things that create whistlers where the frequency, imagine a train going by and how the frequency of the train whistle will change. So we'll be looking for those phenomena and perhaps something new that we haven't thought of.
And can I ask a follow-up?
Yes.
So, Linda, if you wouldn't mind, you've talked about Saturn's rotation, and everyone does a lot of arm waving. What is it about this end-of-mission period that makes you more confident, as I understand it, that you will actually be able to nail the rotation?
Well, this end of mission will not necessarily help us nail the rotation period because we'll have had 22 orbits to try and look for this very tiny offset. We were hoping perhaps getting closer to Saturn would give us a better look at that tilt. And we now know that the tilt between the magnetic field axis and the rotation axis is less than 0.06 degrees. And so we're still trying to tease out what might be a very subtle tilt, which would produce a wobble leading to the rotation rate for Saturn's interior. And it's important to know that because that's sort of ground truth from which we can measure the wind speeds and wind directions and will tell us more about the circulation model for Saturn itself. But that final orbit may not provide sort of the smoking gun for the rotation period.
Okay, the next question is from Tracy Watson at USA Today.
Thank you. Just wondering how low below the surface, quote unquote, of Saturn you expect the probe to go before it breaks up, and also I'm wondering whether Cassini has set any kind of longevity missions for a spacecraft at a planet. Thanks.
This is Earl Mays. I'm going to toss that over to Julie Webster, who has a pretty good timeline for what's happening to the spacecraft as it starts to go into the atmosphere.
We'll actually basically disintegrate. We'll melt long before we hit any real surface of Saturn, whatever it is in the atmosphere, in the gas. Not too long after we lose signal, we'll have already started to be 200 to 500 degrees centigrade within seconds. So we'll start to melt all parts of it.
I think we have. This is Earl again. Probably we've got to give the nod to Voyager for a planetary mission with a long life. And on the inner planets, we have some very long-lived Mars missions. But I think we have the edge on them.
We have the edge on them.
Okay, we're second then. But there is we've got a long ways. In fact, we don't have a long. Yeah, we're not going to make it.
Yeah, Voyager just celebrated its 40th anniversary since launch. So I think for outer planets right now, Voyager holds the record.
But at a planet, we're a contender.
Okay, the next question is from the BBC and Jonathan Amos.
Hello, Jane. I hope you can hear us from England.
We hear you perfectly.
Excellent. That's very good. Quick one for Earl, if I may. What is the separation distance for the KISS with Titan? And then a second one for Linda, because my line was breaking up slightly. Did I hear you say that you thought that the rings were lighter than expected? Because obviously that speaks to their age.
This is Earl. The distance is about 120,000 kilometers. It's not a targeted flyby, so we're kind of letting that float. But regardless of any errors we might have, it's close enough, and it's in the right direction that Cassini's going to not come back.
This is Linda. For the mass of the rings, our very first estimates are for rings that are less massive than we initially thought, which would indeed point to a young ring age. However, that initial estimate has very large error bars, so we first need to really understand and get those numbers down for the Saturn mass itself, and then from that get the leftover mass of the rings. But so far, the direction that we're headed is for less massive rings.
Okay, and the implications for that then if they are less, if they're not as old as perhaps we thought, that means a moon that's been broken up at some point in the past. What are the scenarios that give rise to a young set of rings that we get to see at this special time in the solar system's history?
Well, you're exactly right. For younger rings, it would require a comet or a centaur or perhaps even a moon moving too close to Saturn. Saturn's gravity would break apart that object, and then the remaining bits would go on to form rings. Perhaps that's happened more than once. Maybe some of the differences we see in the rings are from different objects that were broken apart. But if the rings are less massive, that means that they won't have had the mass to survive the micrometeoroid bombardment that we estimate and to have been formed at the same time as the planet. So we're heading in the direction of rings perhaps 100 million years old or so, which is quite young compared to the age of the solar system.
Okay, we're going to jump. Okay, thank you, Jonathan. We're going to go over to Dave Mosher of Business Insider. Dave?
Hey, thank you, Jane. Can you hear me?
Yep, hear you perfectly. Thanks.
Great. I have a hypothetical here with a follow-up. So I suppose this is for either Linda or Earl or perhaps both of you, since you've been on the mission the longest. If you could call all of the shots and choose another mission to launch that's on the scale and sort of cost level of Cassini, what would it be and what would it do? And I have a follow-up after that.
Well, let me take a stab at that. I think we've learned so much about the Saturn system that if I could create a new mission, I'd want to go back. I'd want to go back and explore and try to answer the questions about Enceladus oceans. I'll also carry some instruments to further explore Titan, maybe a Saturn probe. If you had a mission on the scale of Cassini, you could go back with modern technology and modern instruments and start to address a whole list of questions for Cassini. And of course, also, if you look at the planets that Voyager flew by, there are two other worlds, Uranus and Neptune. So perhaps a pair of Cassini-like orbiters, each carrying an atmospheric probe to each of those worlds as well, might be very, very appealing because there's so little. We just know a little bit from those two Voyager flybys, one of Uranus and one of Neptune. So those are interesting targets for me personally to go back to as well.
Yeah, I think, this is Earl, just to pile on to what Linda said, I don't argue with any of that, but I think that the strategic vision has always been, we try to, first we would crash into things because we weren't good enough to fly by them, and then finally, then we began to reconnaissance. And Voyager did the great reconnaissance, and we've since gone back to Jupiter and Saturn with orbiters and probes. And Uranus and Neptune, I expect to yield as many surprises and mysteries and answers as the other two. So we need to keep our eye on that long-term plan. At the same time, Cassini has turned everyone's head about ocean worlds. We have to not ignore that. So I'm a little bit selfish about this, but I think we need to do both. But if we can't ignore the rest of the solar system. It's just too compelling.
Okay, and a reminder to reporters that you can still press *1 if you would like to ask a question. In the meantime, I'm going to go to a couple of people on social media. Grant on YouTube asks, even with the success of the spacecraft, is there any part of the mission you wish you could have had more time with? And will this become part of a next mission?
Oh, I got a great answer for that. I think we could easily use another 22 or 44 grand finale orbits, that there are so many surprises and questions that if I could pick any part of the mission to last longer, I'd choose the grand finale phase.
Well, this is Earl. I wouldn't disagree with that, except that Enceladus is still appealing and calling back for more as well. As many questions as answers there. But the grand finale, given how benign this environment is, it is, in hindsight, something we could have jumped into much sooner in the mission. Now, we didn't know that, and I'm not feeling too regretful of the decision, because but now that we know, it's a place we would be very happy to spend more time.
Right, if we had more fuel, perhaps another 10 years at Saturn would be just about right.
All right, the next question, and you may possibly all want to jump in on this, so Kurt, if you have a thought on this, Mayank on YouTube is asking, what has been the most exciting discovery according to those of you on the team?
Well, I think for me personally, it must be Enceladus, to actually see this plume of water vapor and water ice particles coming out of the south pole of a moon that's only 300 miles across was absolutely astonishing. And then to take instruments built for other purposes and turn them toward sampling and flying through the plume and actually measuring the constituents, finding a salty global ocean containing organics, the possibility of hydrothermal vents, and just revealing a world that we thought was completely frozen solid when we first got to Saturn.
Yeah, I would say this is probably less a discovery than an accomplishment. And for me, seeing those first images from the surface of Titan that the Huygens probe played back in 2005, the collaboration both internationally and mechanically and electrically, everything else between three space agencies actually, and all these thousands of people on the ground to put a probe onto Titan, capture its signal on the way down, land it softly on the surface, and play those images back. I still give myself goosebumps just seeing that first image. I'll never forget it.
This is Kurt. I would agree with Linda. Enceladus has no business existing, and yet there it is, practically screaming at us, look at me. I completely invalidate all of your assumptions about the solar system. And it's just been a remarkable opportunity to study Enceladus and to unveil the secrets that it's been keeping. It's an amazing destination.
All right, thanks all of you for those insights. We're going to now take a question from Irene Klotz of Aviation Week. Irene Klotz, are you there?
Yes, can you hear me?
Yep, we can hear you, thanks.
Thank you. I have two questions. The first is for Earl. Beginning from when, after Cassini entered Saturn's orbit in 2004, how much fuel was aboard at that time, and how much will be left, if anything, at the end of mission? And I have a question for Linda as well.
Okay, hi Irene. I'm going to turn that into a two-part question because we've got two different rocket systems on board, as I think you know. The bipropellant, we started with 3,132 kilograms of propellant divided between the two systems, 3,000 for one, 132 for the other. We are down to about 10 kilograms in one, and probably, Julie, what have we got, about 50, 30 on the other. So we're about 40 kilograms out of about 3,132 loaded. The main engine is empty. We could run out the next time we fired it, but we still have plenty of propellant left for the attitude control system.
Okay, and will anything be left at the end of the mission, or will all the remaining fuel be used by the thrusters to kind of battle against the atmospheric pull?
Go ahead. Julie's going to...
Yeah, Irene, we'll probably use about 3 more kilograms of hydrazine, maybe 4 total, depending on how long we can fight that last entry. But I expect to go in with about 27 kilos of hydrazine. And again, as Earl says, we've already determined that we would not fire the main engine again, and I expect that there's almost nothing in there.
Okay, thanks. And then just a quick one for Linda. What is the difference between the in situ sampling of the atmosphere that you're looking to take at the very last data from Cassini versus what's being taken now during these final ring dives?
Well, right now, we'll be getting very similar data to what we're doing now with the dives between the rings. We'll just be sampling deeper in the atmosphere. So if you will, these final 5 orbits are like dipping our toe in Saturn's atmosphere, and that's in preparation for the final plunge, where we'll send back data till the very last second until the atmosphere grows too thick. So we'll get a much deeper profile in the very final plunge. But we are getting some incredible, intriguing information back. By these first looks, we're getting good signal-to-noise for our mass spectrometers to allow us to tease out some information about that atmosphere. And then this complex interaction between the ring particles that are coming into the atmosphere and how they mix and how their chemistry and dynamics play a role. So we've just had a few orbits and are just sorting out some of that information.
Thanks. Do you have a number of kilometers on the difference between the final data take and what you're getting now?
It looks like, Julie's showing me a plot here, it looks like it's about 1,500 kilometers between where we're flying today, where we're flying now at our closest approach, and when we think we'll start to lose control of the spacecraft, lose the signal, and lose the data.
Thanks very much.
Okay, and because we did get a bit of a late start, we'll go past the top of the hour with a few more reporter questions. We'll try to take 1 or 2 more from social media. The next, I guess this would be a last call. If any reporters do have a question, press *1 to get in the queue. Our next question comes from Rebecca Boyle at 538.
Hi, can you guys hear me?
Yes, we can.
Okay. I wanted to ask, I guess, anyone who wants to answer, if you can talk about what we've learned from the images that we've seen. Maybe you have a favorite picture. I know that spectrometers and instruments are very important for science purposes, but the images themselves have also taught us a lot about Saturn and all these moons and all these strange worlds. So I'm hoping you can all speak to that, just what the value of images versus data that we would put on a plot.
Well, I can talk in particular about the grand finale images. In this particular set of orbits, we're getting closer to the rings and to Saturn than we've ever been before. And the rings are absolutely incredible. As we look at some of those pictures, especially in Saturn's B ring, we just see more and more detail as we get closer and go to higher resolution, that those individual ringlets are starting to split up into more ringlets and additional ringlets down to the limits of our resolution. And then we're seeing 2 kinds of clumpiness in the rings, kind of what we call a streakiness and a clumpiness, and somehow those particles are sticking together into long clumps that we can now see in the pictures. And what's so intriguing is you have a region with clumpiness and then a region where it looks like everything, the particles are not clumping, and back and forth. And so in a very short radial scale, you're getting changes. And then the clouds in the atmosphere, to see the detail of those clouds at much higher resolution, some are little fluffy clouds, some look like little dark holes in the atmosphere. Just getting up these close-up views provide unique information. And we're also going to get some, not only we're going to get some radar data on the rings, and we can also have perhaps a radar map and radar images of the rings as well. And our visual and infrared mapping spectrometer also creates images in the infrared at longer wavelengths than the cameras. So a whole host of images. And not only are they scientifically interesting, but these images are incredibly beautiful. Whether you're looking at the hurricane at the North Pole or at the rings themselves, or even these montages of the planets. One of my favorites is the backlit Saturn. So much detail coming back from Cassini.
It's also important to remember that we have an imaging radar. So this isn't visual imaging, but the radar has pierced through the clouds of Titan, mapped the lakes, the rivers, the plains, in a way that we could not possibly have done without something along those lines. So we always throw radar into the mix with our imaging systems because of the remarkable images they have of the lakes and all of the methanologic cycle that's going on Titan.
Okay, and there was one question that ties in, and that's from Lori's on Facebook. Does the grand finale specifically shed light on the origins of the rings?
Yes, the grand finale data will ultimately shed light on the origin. By determining their mass, we'll get a hint about their age. If they're more massive than we expect, then perhaps they could be as old as Saturn itself. We're headed in the less massive direction, and so that means that some object, a comet, a moon, got too close to Saturn and was broken apart. So yes, one of the key goals of the grand finale is to address the question of the ring mass, and you can do that once you're now inside between the rings and Saturn.
All right, we're going to loop back with a couple more follow-up from media on the line. Let's take Leo Enright of Irish Television.
Thanks, Jane. Sorry to Earl Mays for this, but I got to ask a political question, but with a very small p. Earl, you talked earlier about Huygens, obviously, and this is probably a question better pitched to John Cassini. But I just wonder if you wouldn't mind talking a little bit about how important the international collaboration was. And when I say a political question, I actually mean that. I mean, would you be prepared to venture into how important this was in terms of, the State Department, the deal that was done with the State Department and so on that meant that NASA had to proceed? And I don't know how far you're prepared
I think it's in the public record that Cassini was facing cancellation and Huygens came to the rescue. We were really under tremendous budget pressure. The entire agency was, and we have letters. I have copies of letters coming from very high dignitaries on both sides of the pond, advocating that Cassini remain funded in order to, because of course Huygens had no way to get to Titan without Cassini. And, we, on the other hand, reciprocated when Huygens had some technical difficulties. We Cassini, were able to solve those. So I think it's been a tremendous cooperative agreement. But, yeah, there have been some politics, and both sides we very much appreciate the Huygens argument on our behalf in the mid-'90s.
Yeah, I actually sat with John Cassini on a plane from L.A. to Washington, so I know a bit about it. Thanks very much.
It was quite a tense time, but it came out fine. But we needed the help.
All right, we're going to take a question now from Brian Resnick at Vox. Brian?
Hey, thanks for taking the question. One of you mentioned that Cassini will ultimately melt in the atmosphere. Does this happen just in an instant, or do some components of some of the instruments are they expected to fail before others, or are there will this final demise take place over any measurable time frame? And then
Brian, let me jump in here. We're having a little trouble hearing you. Would you mind if maybe...
is this better? I'm sorry. I'm on speaker.
Yes, that's much better.
Great. So one of you mentioned that Cassini will finally be broken apart when it melts. I was wondering, does that basically just happen in an instant, or is that drawn out? Will there be some components of Cassini that stay on longer than others, or is this just, a piece of flint or a piece of lint in a fire? And then I'm also wondering, does then Cassini leave any permanent trace on Saturn? Is it introducing some elements that never existed there? Will there be any discernible mark it makes on this planet after it's all disintegrated?
Well, that's a question. First part, clearly for Julie. Have you got that timeline memorized?
Yeah, I got the timeline pretty well memorized. It goes really fast. It's a matter, it depends on what you call an instant, but it's 30 seconds to a minute to get from first the blankets will burn off, just like you see when you re-enter the atmosphere on Earth, the ablative shield, and then we'll reach the aluminum melting point within about 20 seconds, and then we'll hit basically the iridium will be the last thing to melt, and it will go about 30 seconds after the aluminum. It goes within a minute.
Wow. And then does Cassini then leave anything, any permanent mark on the planet, or anything left behind?
I think that's a good question for Linda, but I think all the elements of the universe should be there, right?
Right. I think the mass of Cassini is so small relative to the mass of Saturn. We will have some ground-based observers watching to see if there might be a flash or something discernible, but the plunge is actually on the day side of Saturn near local noon. It's about 9 degrees north latitude. But I think the mass of Cassini is so small that those molecules of Cassini will spread out around Saturn's atmosphere. And probably the most unusual might be the plutonium. I don't think that Saturn naturally has much in the way of plutonium.
Okay, we have time for a couple more questions. Let's go to Dave Mosher of Business Insider for a follow-up. Dave?
Yeah, thank you. You could have made a better segue because I wanted to get to this question earlier when addressing my hypothetical. As I understand it, the Department of Energy won't reach full-scale production of plutonium-238 for another 6, maybe 7 years. And I'm curious, with this sort of imperative or big idea to go out to Uranus and Neptune or perhaps orbit Pluto, are all of you, I guess, confident that there will be enough plutonium to make a mission or missions like that possible when the time comes to launch them? Because right now there's a pretty small supply in the storehouse, and it's decaying every year.
Yeah, this is Kurt. I can answer that. NASA is actually working with the Department of Energy to restart. In fact, we have restarted domestic production of plutonium, albeit on a small scale. We have the ability to ramp that up if we need to produce more to fuel any future missions we have. And we actually have plutonium already in hand that we could use for our nuclear power sources as well. And in fact, the mission competition that's currently underway to select the 4th New Frontiers mission offers up nuclear power sources for the mission proposers to use. And it offers up to 3 of those power sources to be available for 2024 to 2025 launch.
Yeah, also, just to add that the plutonium that we carry on board Cassini isn't dangerous. Basically, we use the decay of the plutonium, the heat it generates, to generate the electricity.
Okay, and I guess we're going to take our final question from Marcia Dunn of Associated Press, who has a follow-up. Marcia?
Yes, hello. Thank you. I'm just wondering, will the plutonium on board make for a slightly bigger flash as it's dive bombing into the atmosphere? And might any of that get out to Enceladus or any other potentially habitable moons? And my second question is just a general, that now that we're just a few weeks away, is it finally hitting home, the end of this mission for you personally?
I could address the plutonium question. It probably won't. This is not a fissile isotope, and so it's just going to melt. And it's clad in iridium containers that were to keep it safe during any potential mishaps during launch. So the very highest melting point material on the entire spacecraft is keeping the plutonium enclosed. So it's just going to be a liquid that will, when the iridium finally melts, just dissipate into the atmosphere. And it is going to be so hot in Saturn that it will quickly dissipate. I don't suspect there will be anything more. The signature we'll probably see more likely would be of the flashing material early in the demise of Cassini, because it gets deeper in the atmosphere. And I think any possibility of it escaping is nil.
Yeah, I think Saturn has a very deep gravity well, and at the speeds we're traveling, no parts of Cassini will come out of Saturn, essentially. And then, as the mission draws to a close, this is in many ways really a tough time. Looking back over the course of the mission, I think in particular Since sort of the Cassini family were reminiscing about, remember when this happened, remember when that happened, planning special events around the time of the final plunge. But also, along with that, I feel a tremendous sense of pride in all that Cassini has accomplished. In so many ways, we've really rewritten the textbooks on the Saturn system. Literally, we have new books coming out about Saturn, the rings, the magnetosphere, so many new things Cassini has discovered, and I'm very, very proud to have been a part of that. And, Cassini has been a great mission. We planned this end. We had the fuel last exactly the amount of time we needed to get to Saturn summer solstice. So it's time. It's time to take our knowledge and information and then move that out into future missions to the outer planets and beyond.
And how fast will Cassini be going at the very end? I'm sorry, that's my very last question.
Are you European or?
I'd rather have it in miles. I'm U.S., but I'll take either.
6,000 miles per hour.
I'm sorry, 6,000 miles per hour?
76,000 miles.
76, thank you.
All right. Thank you, Marcia. Thank you to all the panelists who spoke today. Thank you to the reporters for joining us. And we had some good social media questions as well, so thanks for those who followed along that way. Do want to let you know that this telecon will be archived. There are a couple of ways you can rewatch it or re-listen to it. Within 2 hours, it will be up on instant replay. Dialing in a toll-free number is 888-568-0771 or 203-369-3482. That one is not toll-free. And the passcode is 882917, 882917. We'll put that up on the telecon page so people can, if you didn't catch that. Also, if you want to watch it archived with visuals, it'll be on Ustream in a little while, and that's www.ustream.tv/NASA-JPL2. And later on, it will be available on YouTube as well. So multiple ways to relive the excitement. Okay, so there's lots more info about Cassini, including a brand new press kit and information on how you can follow along with the Cassini finale events, and that's online at saturn.jpl.nasa.gov/grand finale. And we also have the news release posted there that went out in conjunction with this telecon. All right, thanks, everybody. Have a great day.
Right.